Hi class, how are you today? Okay, the learning target for today is to solve for segment lengths in a circle. For a scale, you're a 3 if you can solve for segment lengths in a circle. 2, you can find segment lengths if you don't have to use the Pythagorean theorem. 1, you can identify the relationship between radii and chords of a circle. Remember, radii is just the plural of radius. There's many of them. And 0, you cannot identify relationships between radii and chords of a circle. And yes, we will be using the Pythagorean theorem a lot. Let's get started. Alright, so first I have a couple theorems for you. So the first one is a radius bisects a chord if and only if the radius is perpendicular to the chord. Now, quick thing, if and only if. Whenever you see if and only if, that means it works both ways. So this theorem here actually says two different things. It says that a radius bisects a chord if the radius is perpendicular to the chord, but it also says the backwards. A radius is perpendicular to a chord if that radius bisects the chord. So it works both ways. So if it's perpendicular, then it bisects it. If it bisects it, then it's perpendicular. Works both ways. So that's where we can say if this is a right angle, if it's perpendicular, then the chord is bisected. So the AE and EB would be congruent. Or it works in the other direction, where if AE was congruent to EB, then angle AEC would be a right angle. The lines would be perpendicular. Then the second theorem. Two chords are congruent if and only if they are equidistant from the center. So what you do with that is, again, if and only if, so it works both ways. So if two chords are congruent, then they're equidistant from the center, or if two chords are equidistant from the center, then they are congruent. Works both ways. So these are lines from the center to the chords. So if these are congruent, then that means these two are congruent. So if they're equidistant, then the chords are congruent. Or if the chords are congruent, then they're equidistant from the center. Alright, now for an example. Say we have the measure of angle CDA is 90 degrees. So CDA is 90 degrees. So this is a right angle. And we know CE is 5. So this length here is 5. And DE is 2. So this length here is 2. So we can mark this as a 2. And we'll just know that the whole thing equals 5. The whole CE is 5. And what we want to find is AB. So the radius intersects the chord at a 90-degree angle. So based on one of the theorems we just covered, that means AD is congruent to DB. Now, that on its own still doesn't give us anything. However, with radii of a circle, they all are equidistant to any point on the circle. So, if CE is 5, that's the radius, we can go from C to any other point on the circle, and it would also be 5. So how about we go from C to A? And that is also 5. Also, if we know CE is 5 and DE is 2, that means CD is 5 minus 2, which is 3. So now we have a right triangle with measures 3 and 5, and we need to find this line here. So we can use the Pythagorean theorem. A squared plus B squared equals C squared. So in this case, 3 squared plus B squared equals 5 squared, or 9 plus B squared equals 25. Subtract 9 from both sides. B squared equals 16. Square root both sides. B equals 4. So we now know that side AD is equal to 4. And as we figured out before, DB is the same length, so that is also 4, meaning AB is 8. So just as a note, as I said before, we're going to be using Pythagorean theorem a lot. Not always, but a lot. So always keep the Pythagorean theorem in mind and always try to make a triangle out of it. So now we're going to talk about the rules of intersecting chords. So notice I've drawn here that we have two chords, AC and DE, intersecting each other. So the rule with that is that if you multiply AB times BC, the two parts of the chord that have been intersected, that will equal DB times BE. The other two parts of the two parts of the other chord that were intersected. So you've got AB times BC is equal to DB times BE. So that means if you've got, say, this side is 10 and this side is 3, and then this side over here is 5, and we want to know this side, what we do there is we just say 10 times 3 is equal to 5 times question mark, or x in this case. So we'll call it x. So 10 times 3 is 30, equals 5x. Divide both sides by 5. So x will equal 6. So now here you can use the same rule. So if we take 4 times 3x plus 1, because you've got FG times GH, the two parts, that will equal the other two parts multiplied together, 7 times 2x minus 6. Remember to use parentheses and distribute. So 4 times 3x is 12x, 4 times 1 is 4, 7 times 2x is 14x, and 7 times 6 is 42. Get the x's together first, subtract 12x from both sides. That'll give you 4 equals 2x minus 42. So then add 42 to both sides, which will give you 46 equals 2x. Divide both sides by 2, and that'll give you x equals 23. And I asked you to find GI. So now that you know x is 23, JI is JG plus GI. So JI is going to be 2x minus 6 plus 7. So 2 times x, so 2 times 23, is going to be 46 minus 6 plus 7, so that'll be 47. So JI is 47. Alright, now time for the sponge activity. So, on number 1, I want you to find DE, knowing that BC is 22 and AF is equal to AG. And then in number 2, you have that circle P has a radius of 10, AB is perpendicular to DE, and then in part A it says if AB is 8, what's the length of AC? And in part B, DC equals 2, what is the length of AB? Just to note, this AB is different than this AB. So just don't already go ahead and say this is automatically 8. They're different ABs. Saying if AB is this, then what is AC? And this is saying if DC is this, then what is AB? Alright, that's it for the lesson. Once again, please make sure to take notes on the entire lesson. Attempt the sponge, rank yourself, take a picture of everything and submit it all to eBackpack, and have a good night.